So this video is for integrated 3. This is dealing with the notes on binomial probability. And to figure out binomial probability, we're going to be using the idea of combinations, which you see the formula for right here. This is probably in a notation where it may not be used to. In integrated 2, you might not have seen it like this. I'm going to get up this website here, Math is Fun, where they show formula for combinations. So normally we see it in this form. And again, we read this n choose r. So n choose r is equal to, and another way of writing n choose r is this parenthesis with an n on top and an r on bottom. This means the same thing, n choose r. So what we're doing is we're choosing r items, groups of r, okay, groups of r items out of n. So the formula is n factorial over r factorial times n minus r factorial. Now the r and the n minus r, those together are going to add up to n. So whatever adds with r to get n, that's what this n minus r is. Now in this example down here, they were talking about getting out of 16 pool balls 3. So basically what they were doing, let me just grab a pen here. Basically what they were doing is they were trying to figure out of 13 items, how can we, 16 items. Out of 16 items, how many different groups of 3 can we get? Now, what they did was they took this 16, which is the total, factorial, right here, 16 factorial. And then they took how many items we want, which is 3. And then there's your 3 factorial. And then what do I add with 3 to get 16? Well, 13 plus 3 gets us 16. So right here, they wrote 16 minus 3 or 13 factorial. And they worked that out and got 560. Now, if I was going to put it into Desmos, right now I have Desmos up, but the Desmos I have up is actually the scientific notation Desmos. Scientific graphing calculator Desmos, but it's very much like the regular Desmos that we're used to using. So if I wanted to go to combinations, I'm going to go to functions, and here's combinations. So if I want to do 16 choose 3, I put 26. 16 choose 3, you see we got 560. Now, since on bottom we have a 3 factorial times a 13 factorial, this is not going to be any different if we have the following. I'm just going to get my cursor here. If we have the following, and instead of having the 3 factorial first, we have 13 factorial and 3 factorial. That is going to be 16 choose 3. And so if I do 16 choose 13, you see I end up with the same answer. So something that you want to understand when you are doing these combinations, it's going to be kind of helpful here, is that when you're doing this, let's say, for example, okay, let me just move this for a second. And let me just get to this here and clear all my drawings. Okay, so if I am working out, for example, the following. Let's say I was doing 3 choose 0 and 3 choose 1 and 3 choose 2 and 3 choose 3, just kind of as an example. 3 choose 0 would be 3 factorial over 0 factorial times, what adds with 0 to get 3? 3. This one here, 3 choose 1 would be 3 factorial over 1 factorial. And what adds with 1 to get 3? 2. 2 factorial. For this one, 3 choose 2 would be 3 factorial over 2 factorial times what adds with 2 to get 3? 1 factorial. And then this one here, 3 choose 3 would be 3 factorial over 3 factorial. And what adds with 3 to get 3? 0. Now, if I was, and just kind of a little side note, 0 factorial is equal to 1, just so we understand that. Okay, so if I was to put that into my calculator here on the side, 0 factorial, you see I do get a 1. I just want us to kind of understand that. Now, what I want us to see is that when I'm doing this combination and I'm doing 3 choose 0, okay, you see I get 1. Now, if I was going to do 3 choose 3, because 0 plus 3 both add up to 3 together, you see I get the same thing. So this one up here, let me highlight this. This one here is, let me get my pen, sorry. This one here and this one here are going to be the same. And why are they going to be the same? Because again, whether I do 0 factorial times 3 factorial or 3 factorial times 0 factorial, multiplication's commutative, which means that it doesn't matter if I multiply 0 factorial and then 3 factorial or 3 factorial and then 0 factorial, I'm going to get the same answer. And you see that that's the case here. Now, again, if I was doing 3 choose 1, for example, that is going to be the same as 3 choose 2, because 1 and 2 add up to 3. So, for example, let's say I was going to do 7 choose 5. Now, 7 choose 5 is going to be the same as, you got to ask yourself, what adds with 5 to get 7? 2. So that is going to be the same as 7 choose 2. And you see that I got the same answer over here. So I want us to understand that. Okay. Now, let's take a look at this situation here. So what's happening here with binomial probability? Basically, you're going to take the probability of a success and the probability of a failure. So for example, if I'm talking about rolling a single die, we can have a 1, a 2, a 3, a 4, a 5, a 6. If I was going to say, what's the probability of getting a 1? Well, that's 1 out of 6. Probability of getting a 2, that's 1 out of 6. Now, what we're going to be looking at is not the probability for each outcome, but let's say I'm going to look at the probability of getting a 1 and the probability of not getting a 1. So I'm just going to jot this down as an example, okay, just real quick. So if I am dealing with a single die, okay, and I want the probability of a 1, well, the probability of a 1 is a 1/6. Now, what's the probability of not a 1? Well, the probability of not a 1 is 5 out of 6. That's what we're looking at, getting something or not getting something. Together, those two probabilities add up to a whole. Okay, so that's something else that we want to understand. So when we are doing this, and they are saying that we're going to do a binomial probability, again, probability of a success versus probability of not getting that success. So in this situation, they're having n represent the number of times your trials, okay? Maybe you're flipping a coin 5 times, something like that. P being the probability of the success. So for example, with rolling the, let's say we're rolling the die, okay? Like we're doing this dice, and let's say we want to get a 1. So we have 5 rolls. Well, 5 would be the number of trials. The probability of a success in our case would be 1 out of 6 if we're trying to get a 1. Probability of a failure in our case would be 5 out of 6 because there's 5 ways to not get a 1. The number of successes in n trials, let's say we want to get 3 1s. Okay, so that means I'm going to get 3 1s and 2 not 1s. Okay, so if I was doing a problem like that, what I would do is if I was going to have 5 tries, 5 rolls, okay, let's say of the die, and we want to get, let's say, 3 1s in that situation, what I would be working out is 5, choose 3. And I would be multiplying my successes, which would be 1 6, and my failures, which are 5 6. Now, I want to have 3 successes, so this is going to be to the power 3. Now, if I have 3 successes out of 5, that means I have 2 failures. And that is how I would find the answer. So if I was to work this out, let me just clear all of this. I would be, let me get my combination. I would be doing 5, choose 3. And I'm going to be timesing that with the quantity 1/6. Let me get out of the denominator, sorry. 1/6 raised to, and here, let me stretch this out so we can see this. So 1/6 raised to the power 3 times the probability of a failure, which would be 5 6. And again, if we have 3 successes out of 5, that means we have 2 failures. So I'm going to raise to the power 2. And this would be our probability, 0.03215. So about 3.2%. Okay, that's what we're going to be doing. So let's try doing some of these problems. Okay, so this first one, and let me just move this a little. Okay, so a fast food restaurant is attaching prize cards to every one of its soft drink cups. The restaurant awards free drinks as prizes on 3 out of 4 cards. So the probability of getting a free drink is 3/4. The probability of not getting a free drink is 1/4. Okay, so let me just kind of jot that down. So probability of free drink is going to be 3 out of 4. And probability of not free drink is 1 out of 4. Okay, suppose you have 3 cards. Find the probability. Okay, find the probability. So we have 3 cards. Find the probability that exactly one of these cards reveals a free drink. So we're going to go 3 cards, choose 1 success. So a success is a free drink, which is going to be 3/4 raised to the power 1 times a failure, which is 1/4, and raise the power 2, because we want exactly 1 success. And we're going to put that in our calculator. Quick note, 3 choose 1, anything choose 1 is going to be that number. So if I do 3 choose 1, that is a 3. Just going to throw that out to you guys so you know that. Times 3/4 raised to the power, whoops, got to get my parenthesis in here. Okay, so 3/4, one more time, 4.75, might have been easier for me to type. Okay, so 3/4 raised to the power 1, which I don't really need, times 1/4, oops, times, what happened here? Times 1/4 raised to the power 2. Okay, let me make sure all of that got in here. So 3 choose 1 times 3/4 to the power 1 and 1/4 to the power 2. And we got 0.140625. Okay, so we got 0.140625, which is going to be about 14.06%, but you can leave it as a decimal. Okay. Example 2. Alicia walks to school with her friend, Juanita. Juanita is on time 80% of the time. What is the probability that she'll be on time 5 days in a row? Okay, so we're going to have basically probability of on time is 80% or 0.8. So the probability of not on time is going to be 20% or 0.2. Now we are going to have 5 trials, so it's going to be 5 choose, and we want all 5 days to be a success, that she's on time all 5 days. So that's going to be 5 choose 5 times 0.8 to the power 5. Now what's always going to happen is this power here and this power here are going to match, okay, times 0.2, and 5 plus what gets us 5? 0. Now a quick note, 5 choose 5 or n choose n is always 1. And 0.2 to the power 0 is also a 1. So really, all I need to put in my calculator is 0.8 to the power 5. Now, just to show you, to make sure you understand that combinations 5 choose 5 is a 1. Okay, again, anything choose the same number is always a 1. So basically, all I need to do is 0.8 raised to the power 5, and that's going to be a 0.32768. So about a 32.77%. Example 3. A calculator contains 4 batteries. With normal use, each battery has a 90% chance of lasting for 1 year. So the probability of lasting 1 year is 90% or 0.9, which means the probability of not lasting 1 year is the rest of that, which is 0.1. So what is the probability that all 4 batteries will last a year? So that's going to be 4 choose 4. 4 batteries, all 4 of them being successes. So that's going to be 0.9 to the power 4, raised to the power 4 times 0.1 raised to the power 0. Again, this here is a 1. This here is going to be a 1. So I'm really just going to put in 0.9 to the 4th power. So 0.9 raised to the 4th power is 0.6561. So about 65.61%. Example 4. When it rains, there's a 70% chance that the practice will be canceled. If it rains for the next 3 days, what's the probability that Malcolm's practice will be canceled? And this is where you got to be careful. At least one of the days. Okay. So probability, I'm just going to say no practice, is 0.7. Probability of practice, where they didn't cancel it, is going to be 0.3. Now, we're talking about 3 days, but we don't want exactly 1. That would be 3 choose 1. We want at least 1. So at least 1 means 1 or 2 or 3. So we are going to have to do 3 choose 1 plus 3 choose 2 plus 3 choose 3. Okay. Now for 3 choose 1, that's one success, and our success is having no practice. That's going to be to the power of 1, which means having practice is going to be 0.3 to the power 2, because 1 plus 2 is 3. Now 3 choose 1 is going to be 0.7 chance of practice being canceled. That would be 2 days canceled and 1 day not canceled. And then 3 choose 3, 0.7 to the 3. That means all 3 days are canceled. And so 0 days are not canceled. Okay, the 0 days we have practice. Now, again, I'm going to put this into my calculator. Just again, a quick note. This is going to be a 3, remember. This is also going to be a 3 because 2 plus 1 is 3. So if I put that into my calculator, I'm going to get the same thing. And this here is going to be a 1. And this here is also going to be a 1. Just kind of giving us some things that can make it a little faster math. And then again, so just again showing that 3 choose 1 and 3 choose 2 are both going to give me a 3. And 3 choose 3, whoops, is going to be a 1. Okay, so if I put this into my calculator, again, I don't have to do the 3 choose 1. I can put in a 3. That's going to be a 3 times 0.7 to the first times 0.3 to the second plus, and let's see if I can pull this out, and so I don't want it to expand all the way, and then pull this down so I can see what I'm typing in. Okay, plus, and then I'm going to do 3 choose 2, which is also another 3, times 0.7 to the second times 0.3 to the first, which is going to be a 0.3, plus 3 choose 3 is just a 1, times 0.7 to the third times 0.3 to the 0, which is again a 1. So I got 0.973. 0.973. Just move this. Oops. This back here. Okay. So 0.973. So this whole thing is going to equal 0.973, 0.973, or 97.3%. Now, something I want us to notice is when we're talking about these binomial probabilities, and if we're dealing with this situation where we have 3 days, what can happen? So you can have 1 day where your practice is canceled, 2 days where your practice is canceled, 3 days where your practice is canceled, but you can also have 0 days. So really, if I was to take these ones I just listed out and add it with 3 choose 0, let me just write 3 choose 0 times 0.7 to the 0 times 0.3 to the 0 plus 3, this would end up giving me 100%. So really, I don't need to do the 3 choose 0 because that's just a fancy 1. 0.7 to the 0 is a fancy 1. So I am going to add it with 0.3 to the third. Let me see, let me get over here. So let me get this out again. So I'm going to go plus 0.3 to the third. You see, I get 1 because that's everything. I did 0 days. I did 1 day practice, 2 days 1 day canceled, 2 days not canceled, 2 days canceled, 1 day not canceled, and so forth. So I worked out all of that. Let me get this back up. Sorry, I'm just clicking too many things here. And I end up getting 1. So what that means is there's 2 ways I could do this problem. If I want at least 1 day, which means 1 or 2 or 3 days, What did I not have? 0 days. So I can take 1 minus what I did not want, which is 3 choose 0 times 0.7 to the 0 times 0.3 to the third. And if I put this into my calculator, 1 minus, and then again, you can put this in, but 3 choose 0 is just a fancy 1. 0.7 to the 0 is just a fancy 1. So I'm really going to have 0.3 to the third. And you see I got the same answer, 0.973 or 97.3%. So when you have the word at least, you want to be careful because that means you're going to have more than one thing you need to work out. So if it's out of 3 and you want at least 1, that means 1 or 2 or 3. Now, what was missing? 0. So it's faster to figure out what I don't want and go 1 minus than to sit here and work out all of these. Both give you the same answer. Okay, example 5. A scientist hopes to launch a weather balloon on one of the next 3 mornings. Okay, so we have 3 mornings. For each morning, there is a 40% chance of suitable weather. So probability of suitable, I'll just put suitable weather is 0.4, which means probability of not suitable weather is going to be 0.6. What is the probability that there will be, and this is where we got to pay attention. So again, we were going to do 3 mornings. What's the probability of at least 1 morning with suitable weather? So at least 1 morning means, at least 1 morning means 1 morning or 2 mornings or 3 mornings. So what's missing? 0. So instead of finding each of those and adding them together, I'm going to find the probability of 0. So that's going to be 3 choose 0 times 0.4 to the 0 times 0.6 to the third. And again, put that in my calculator. Again, this is going to be a fancy 1. This is going to be a fancy 1. So I am really going to work out 1 minus 0.6 to the third, which is going to be 0.784 or 78.4% chance. Okay, example 6. Now, for example 6, it says, one survey found that 80% of respondents eat corn on the cob in circles rather than from side to side. Assume that this sample accurately represents the population. What's the probability that out of 5 people, you know, at least 2 of them eat corn on the cob and not eat corn on the cob, eat corn on the cob in circles? Okay, that part got cut off. So we're going to work that out. So in this case, we have 5 people and at least 2 of them. So at least 2, we got to be careful with that word. At least 2 of them eat corn on the cob out of 5. So what does that mean? It's at least 2. It means 2 or 3 or 4 or 5, because there's 5 of them. Now, what did I not list out of 5? I did not list 0 or 1. So in this case, I could either figure out 4 different probabilities and add them together, or I can figure out 2 and subtract it from 1 whole. So I think I'm going to do this. So I'm going to go 1 minus, and I want to put brackets around this whole thing because I'm going to be subtracting 2 quantities. Okay, there's 5 items or 5 people, right? So we're going to do 5 choose 0. The probability of them eating in circles is 0.8 to the 0 times the probability of them eating in side by side is going to be 0.2. And out of 5, if 0 are doing circles, then 5 are eating side by side, side to side. Plus, or I can go minus and minus, okay, either way. But I can't put minus and then add these 2. I need to have them in brackets if I'm going to do that. 5 choose 1. That means that 1 is going to eat in circles, which means that 4 are not going to eat in circles. And so I can work that out. And again, just a little reminder that this is going to be a 1. This is going to be a 1, so I don't need to really put that in. This is going to be a 5. Okay. So let's put that into our calculator. And let me make this bigger. And put this down here so I can see it. Okay. So clear this. Okay, so I'm going to go 1 minus the quantity. 5 choose 0, which is a 1, times 0.8, which is a 1, times 0.2 raised to the power 5, plus 5 choose 1, which is 5, times 0.8 to the 1, which is going to be just 0.8, times 0.2 raised to the power 4. And actually, I guess on this, I got to use parentheses, not brackets on Desmos, sorry. So parenthesis around it. And I get 0.99 probability. So this is going to be 0.99328. So this is going to equal 0.99328, or about 99.33%. Okay, now the next one, let me just get my calculator back here. And actually that is the last one here. But what you want to be careful of, sometimes it may not be, if it's an at least, doesn't mean you have to do it the way I did it. In this case, at least 2 out of 5 is a 2, a 3, a 4, a 5. That's 4 things I'd have to work out. Where, what did I not have to work out? 0 or 1, that's only 2. So I would do the one that has the least amount. So we did turn this in for notes. So make sure if you are absent, you fill it out and turn it in and get easy points.